What if the lock that protects your paycheck, your savings, and trillions in trades could be opened by a computer that doesn't exist yet? And what if the smartest move was to change every lock before that computer arrives? This is Dollar's Dance, in which we rig the money with simple stories to reveal the truth, and it's all about money. The locks, the keys, and the quiet race. Let's start simple. Finance runs on math. Math turns trust into action. Logins, payments, trades, custody. Most of that trust comes from cryptography, the art of keeping secrets. Now, a quick human version of Quantum 101. Classical computers think in bits, zeros and ones. Quantum computers think in qubits, like a coin that is spinning mid-air, heads and tails at once until you catch it. Sometimes two spinning coins get linked. Flip one and the other knows. That link is called entanglement. Do we have big perfect quantum computers? No, we're in the NISQ era, noisy, intermediate scale quantum. Think early airplanes. They fly, but you wouldn't cross the ocean in one yet. They're great for demos and prototypes, not for the blockbuster tasks everyone dreams about. So why is finance paying attention? Because of the locks. The first place quantum hits finance isn't trading, it's trust. Your bank app, your company VPN, the messages between banks, the signatures on some blockchains, these rely on public key cryptography, especially RSA and elliptic curve schemes. A big enough error-corrected quantum computer could run Shor's algorithm and crack those keys. Not maybe. Mathematically. Here's the catch. Those big machines don't exist yet. But the risk clock is already ticking because of something called harvest now, decrypt later. Bad actors can copy encrypted traffic today, store it, and unlock it years from now when the hardware arrives. That means any long-lived secret, customer data, legal archives, M&A documents, health records, custody keys, needs protection that will still be strong a decade from now. Enter the new locks post-quantum cryptography, PQC. These are encryption and signature schemes designed to resist quantum attacks. They're built on different math, lattices, hashes, error-correcting codes, instead of factoring big numbers. Standards, bodies are finalizing which ones everyone should use. The plan is to swap out the old locks for new ones piece by piece without breaking the plumbing. There's also a shiny tool called Quantum Key Distribution, QKD. It lets two places share a secret key using the laws of physics. If someone eavesdrops on the line, you can tell. Cool, right? Yes, but it needs special hardware and dedicated links. It's great for a few crown jewel connections. It's not the mass solution for every bank branch or mobile phone. So what should finance do now? 3 simple, concrete moves. 1. Make a list of every place you use crypto. Think like a plumber. Websites, TLS, APIs, VPNs, hardware security modules, HSMs, and key vaults, databases with encrypted fields, payment rails, messaging and custody, smart contracts and wallets. You can't fix what you can't see. 2. Get crypto agile. Build the ability to swap algorithms without rebuilding the whole system. Use hybrid modes, old plus new, during the transition. Rotate keys more often, shorter key lifetimes, fewer long-term headaches. 3. Start small, start now. Pilot PQC in low-risk systems to learn where it breaks. Use quantum-grade random number generators for your most important keys. Train your people. The hardest bugs are usually human. Here's a quick story. Picture a mid-size bank. The head of security asks, "Where do we use RSA?" Silence. Then a trickle of answers: the website, the VPN, the ATM network vendor, the card processor, the cloud provider, the core banking system, the custody partner. Each answer adds another lock. That's why this isn't a flip-a-switch fix, it's a know-your-house fix. One more thing, this isn't just about banks. It's about anyone who touches money: fintechs, broker-dealers, custodians, exchanges, insurers, treasurers. If your business runs on secrets, the timeline for trust is longer than the timeline for hype. So, could quantum computing transform global finance? Yes. But the first transformation won't be speed, it will be safety. The quiet kind, where nothing blows up because someone changed the locks in time. Pricing the world, risk, optimization, and the road ahead. Let's pick up with a different question. If quantum can change our locks, can it also change our math? So much of finance is rolling dice on purpose. That's Monte Carlo simulation. You rerun the future 1,000,000 times to price an option, test a trading strategy, or estimate how much you could lose on a bad day. Quantum promises a neat trick here. There's a method called amplitude estimation that in plain English needs fewer dice rolls to get the same answer. Imagine you could sample 1/5 as much and still trust your number. That could turn overnight risk into near real-time risk. It could let you use richer models without missing the morning meeting. There's a big but. To get that true speed up, you need large, fault-tolerant quantum machines with error correction. We're not there yet. And you also need to load your real-world data into those qubits efficiently, a step that's harder than it sounds. No free lunch. So what's useful now? 2 practical lanes. Quantum-inspired algorithms. Ideas from quantum research are tooled for classical computers. Banks use them today to speed up certain optimization problems, scheduling, routing, matching, without a single qubit. It's like learning a chess trick from a grandmaster and using it on your laptop. Hybrid workflows use small quantum chips as co-pilots for narrow subtasks, finding better starting points or sampling tough distributions while the main engine stays classical. Think of it as power steering, not a new engine. Now let's talk about optimization, the quiet engine of finance. It shows up everywhere. Building a portfolio that balances return and risk under dozens of rules. Deciding which collateral to post to which clearinghouse to save on costs. Matching buyers and sellers with the least settlement risk. Scheduling batch payments so liquidity doesn't run dry at noon. These are hard, knotted problems. Classical solvers are excellent, but they struggle when the problem gets huge and the rules get weird. Quantum algorithms like QAOA, Quantum Approximate Optimization Algorithm, aim at exactly this shape. Find a very good answer in a huge search space. Are we beating the best classical methods today? Not on the big, messy, real-world problems that matter most. But the moment a hybrid stack reliably beats classical on an industrial case, even by a little that matters in operations, saving 5% on collateral or shaving an hour off a daily batch is money. What about trading? Does quantum make you faster? Not in the way you might think. In high-frequency trading, the bottleneck is physics, the speed of light through fiber or air. Quantum doesn't make light faster, but offline there's value. Recalibrate risk models in minutes after a shock instead of hours. Run deeper scenario trees before you launch a strategy. Clean noisy data better and pick features smarter. That's not a headline. It's a quiet edge. And quiet edges compound. Zoom out to the system level. Imagine a near-future day. Banks run daily risk with quantum-boosted simulations and tighter error bars. Clearinghouses optimize collateral and margin more efficiently, lowering friction without lowering safety. Post-quantum cryptography protects logins, messages, and custody keys. A few backbone links use QKD for the crown jewels. Central banks run stress tests that include climate, pandemics, and supply shocks, all at higher resolution. Now the flip side. A quantum crisis doesn't need to break the whole internet. It only needs to break belief. If someone demonstrates a crack in a widely used signature scheme before everyone migrates, you get emergency key rotations, delayed settlements, maybe even frozen markets. Blockchains that rely on elliptic curve signatures would need to upgrade fast or risk theft. Big chains could adapt, small ones might not. This isn't just technology, it's geopolitics and standards. Countries are funding quantum hardware and writing the rulebooks for the new locks. Export controls, patents, and talent pipelines shape who leads. In a world where the safe asset is partly a matter of confidence, who sets the standards for secure communication matters, for bond yields and capital flows? So, what should we do? Now, next, later? Now, 0-3 years. Inventory your crypto. Build crypto agility. Pilot post-quantum algorithms in low-risk systems. Shorten key lifetimes. Add quantum-grade randomness for critical keys. Try quantum-inspired optimization where it's cheap to test. Next, 3-10 years. Roll out hybrids in risk and optimization where you see real gains. Use QKD selectively for a few high-value links with strong governance. Expect regulators to ask for quantum readiness, plans, timelines, testing. Later, 10+ years. If fault-tolerant machines arrive, deploy true quantum speed-ups in pricing and risk. Treat quantum as a standard co-processor for complex operations. Prepare for the threat side to mature too. Governance and recovery will matter as much as code. Here's the heart of it. Quantum won't make markets fair or unfair by itself. It won't make capitalism kind or cruel. It will change the cost of some calculations and the strength of some locks. That shifts where profits sit, where risks pool, and whose promises feel safest. In part 1, we said the first transformation is trust, changing the locks before the burglars show up. In part 2, we add the math, small, practical edges that add up over time. Together they don't shout, they whisper. And in finance, it's the quiet changes that move the world. If this was useful, please subscribe. The future does not appear completely at once. It arrives one update, one policy, and one sound decision at a time. You can check out these videos which you don't want to miss.